Hello and welcome back to the lab. In this video we're going to take a second look at this AA501. This is the distortion analyzer we repaired in the previous video. In this video I'm going to go through the alignment process, so there was some interest in seeing that, and we'll see what we can do to bring this back into spec. So the way I've got the lab setting up right now is I've got the distortion analyzer has been on for a while. 7603's on, the multimeters are on, I have both of my signal sources on, so the SG505 and the SG502, both sets of those are on, my function generators are on just in case I need them, my 5200A is on, has been warming up for a while, everything's gone through all of its warm-up processes. And just to give an example on how warm-up is so important, on the 7110, it actually has a counter when you turn it on. It logs an event in its event log that says its warm-up has finished. So the calibrators have been on as long as the 7110's been on, because they need an hour and a half or better to warm up. Everything else in the lab needs about 30 minutes, so it's been on for a little while. I have the calibration document. Here's a lot of our adjustments. There are some adjustments on the sides of the two units, or of the unit. Power supply for this particular unit is a 502 that's been taken out of the case. You can see it's only 2 sections wide. That's probably what I'll be using to do my calibrations and adjustments from now on these 500 series, as long as you only have a 2 slot or smaller. And it's not a high current like a power supply, because the 502 is not a high current. Doesn't have the high current spot. I'll use that for powering the plugins I'm working on, because it gives me a lot of access and I can rotate it and do everything I need to do the adjustment. I was using a 503 frame that I took apart. I will actually probably put that frame back together. I'll have to look at the caps in it, see if it needs a refurbishment before I put it back together. When I checked the power supply rails recently, they were fine, but I also don't hit it very hard because it drives one plug in at a time. But having the 3-bay, I think, would be really good for the low distortion oscillators that I have, the 505s and the 502s. Having them not in a switching supply, even though the switching supplies are very filtered and things like that, I tend to get a little bit better performance out of them having them in a linear supply frame versus a switching frame, but I'm also splitting hairs at that point because we are most definitely down in the noise. Oh, in terms of frames, a 5000 frame will drive 500 plugins, but a 500 frame cannot drive 5000 series plugins. They can't. The 5000 series plugins actually have an additional port in the back of them that the 500 series frames don't have. So perfectly safe to plug a 500 plug-in in a 5000 frame. Physically not compatible plugging in a 5000 series plug-in into a 500 series frame. Hopefully that clears up some confusion there. So with that, we'll get started with the alignment. Okay, we're just getting started, and there's something that's not clearly defined and labeled. So we're adjusting the 5-volt rail. Here's the test points: ground, negative 5 volts, positive 5 volts. The other 2 test points are negative 15 and 15, and I'll check that. The resistor we want to adjust is this potentiometer right here, and we want to adjust that for 5.25 plus minus 0.1. And here's how we turned out on that test point. It's bouncing a little bit, not a huge deal, because I'm allowed 0.1 and I'm within a couple of hundred microvolts. Just move it over while I get the camera focused in on the meter. We'll check the 15-volt rails. Here is negative 15. Looks okay. There's also no adjustment on these rails, so I'm just sanity checking them. And that's good too. So well within spec on the negative and positive 15 volt rails, and they're very close to each other, so awesome there. One other thing to note while I'm moving everything around, the pass elements on this side of the frame are right here on this, mounted to this metal. This is incredibly warm to the touch. It's pretty toasty. Definitely uncomfortable if I left my hand there for a while, so I am being very careful as I move this around, and also when I grab that side, because those pass elements are running a bit warm. Okay, I have the scope hooked up. What it wants me to do when the scope is hooked up to the function output, it wants me to poke these two buttons back and forth and see how it's reacting on the scope. I'll show you what I'm looking at. Okay, this particular measurement wants me to be slower to make it easier to see. I sped the scope up a little bit, so I'm running the scope a little bit quicker. But as I move these, that's on 0.2, now 2. See how it kind of jumped? So it's kind of jumping to about here. When I do that, they want to get the jump to be as small as possible. And what I'm adjusting is the distortion amplifier offset R 1050 right here. So let's see if we can improve this a bit. Yeah, see, now it's really jumping around. I'd say that's good right there. There's 0.2, there's 2. Perfect. Yeah, and we're on 200 millivolts and 500 microseconds. So that is spot on where we want it to be. So that's it for the distortion amp offset. Next is the RMS 0, average 0, and QPK 0. Okay, I'm checking the amplifier compensation one more time. Reason I'm checking is because I forgot to short the output, or the input. So I was just double checking it with a shorted input to make sure everything was still good. It is, so we'll move on. Okay, here's a bit of a difference in some meters. I double checked it with my 7510, 15.0012 millivolts. I have the calibrator set to 15.0 across the board, and I'm reading pretty good. We're bouncing in the ones of microvolts, so way down in the noise. But watch this when I move this to my 6.5 digit meter. Just the difference between the two meters. I trust the 7.5 digit more. So the calibrator output actually is spot on. I was starting to think the calibrator might be a little low. Turns out my meter may be a little low. Always good to bounce everything off a meter. So because I've confirmed it with the 7.5, I trust the calibrator now more than I trust this meter. Okay, we just have a 15 millivolt signal coming in from the AC calibrator. I need to adjust something on the top panel. Let me figure out what. R1030. 1030 is going to be here. Not the very back hole, the one closer to the camera. The null trim. Make sure this is in RMS. It is. So I need to slowly adjust 1030 until 0.15 shows up. Okay, because this is an option 1 instrument, I actually need to do 1035, which is right here on the main board. And it wants it to just be 15, so let it kick over and we're done. It says maintain the test setup so we don't change anything. Volts on level, which is correct. And RMS, which it still is. 1.5 volts. Okay, we need to adjust 2057, which is right here. Since this is an option 1 instrument, this is in different places if it's an option 2 or a no option, but we want a reading of 15.0. Okay, what's going into the front of the unit is a 1 volt 60 kilohertz sine wave, not 60 hertz, 60 kilohertz. And I'm supposed to note the display readout, 1.007. And I need to change the input range to 20 volts. And I'm supposed to change this to 10 volts. Let me confirm that on the 7.5 digit meter because I'm sure that's off. Actually, it's not. It's not off. It's pretty spot on. So the compensation's off badly. So my adjustment for the antenna attenuator compensation is right here, 2061. So I need to adjust that cap. Okay, I had to fight with that one for a little bit because it's pretty deep in there, and I only had a metal tuning tool. My non-inductive tuning tools are too short. They wouldn't go all the way down to reach that cap. I needed 1007. It kicked down a little bit. As you saw, it was 1007. That's also because I'm moving around in the lab. But I'll adjust that again here real quick, but it is good to go. Well, after fighting me for a little while, I dug out my box of other tuning tools, and it didn't have a choice. It's a 10007, exactly where it needs to be. Okay, we're doing the dBm adjustment, so I have 0.7746 volts RMS at 1 kilohertz into the front of the 501, as confirmed with the 7510. And I need to adjust this guy right here. So this is the middle of the 3 pots that are right there for 0 dBm. Pass a little bit. Boom. There we go. All right, next step is I need to change the voltage calibrator to 77.46 millivolts RMS. And I need to adjust our 2160 for the negative 20 dB. So I'll get that set up, and I'll bring you guys back. And it looks like my negative 20 dB doesn't need adjusting at all. It's all set. Calibrator set correctly. If I did need to adjust that one, it would be this hole right here, down through the top of the unit to that pot. That one's good. Don't need to mess with that. Okay, so I have 7.746 millivolts RMS of signal going into the front of the 501. And I should be at negative 40 plus minus 2. I need to adjust 8091. 8091 is actually right here. It's the one on the left. Wrong way. Negative 40 dBm. Now it wants me to repeat that all again a few times. So let me check. Let me just run through it a few times, make sure they're all correct, because this is a balancing between the 3 because they all interact. Won't do that on camera, but I'll bring you guys back for the next step. Okay, after rolling through it, it actually didn't need any further adjustment. So we'll 0 dBm. Perfect. Negative 20. It actually locked up. Let me turn it off, turn it back on. It didn't lock up. My calibrator went to standby. 0 dBm. Negative 20 dBm. And if I wait for it to figure out the noise, negative 40 dBm. So there we go. Not too worried about the last step where it took a while to get there. The notch filter does have to work really hard. The unit's open. This is an incredibly noisy environment. This is not a shielded cal room by any stretch of the imagination. There's switch mode power supplies everywhere. There's two massive computers behind me. Like, it's... I control noise to the best as I can, but it's everywhere down here. Okay, this is the offset gain adjust. I have 7.746 millivolts RMS going into the front. You can see it kind of bouncing back and forth like it doesn't quite know what it wants to do. I want to give it a little more to stabilize that display, but not too much. I need to adjust R811, which is the last one in that trio of pots at the bottom of the logic board. It's the one that's, of the set of three, it's the one closest to the front of the display. And there we go. That did not need much adjustment. I just kind of tweaked the pot a little bit and it stabilized, so it's good to go. Next is the DBR0. Okay, so I have the signal set up. It's 0.7746 volts RMS at 1 kilohertz. Hit the DB0 reference. This should be 0 and it should be stable. If it was plus or minus, we'd have to adjust it. This one's actually perfect. So don't need to touch that control. If we would have had to do something, it would have been this potentiometer right here. It's the closest one to the front panel on the side at the bottom. And that is on the logic board. Okay, so there's a lot going on here. I have the SG505 coming in with a 400 kilohertz signal at 0 dBm. The SG505 is floating off of ground. I have this hooked up to the dual channel scope, so channel 1, channel 2, triggering on channel 1. I need to do the null trim. Don't need to do the scope just yet, but I need to adjust this for the lowest display reading. So let's go ahead and do that. It's 10:30. Okay, the environment's a little too noisy for me to do this with the display because it's jumping around, and this gives you an idea on how noisy my environment is. Here's my fundamental. This is all really good coax. This is all Tektronix coax, so it's not the cables or anything like that. But this is how much noise is coming through on the output. So that pulsing that you're seeing, that's that chirp noise that I keep talking about in my videos. I still don't know what does that. But what I did was I tuned the... I'm supposed to tune out the fundamental with the nulling, and I tuned this for minimum amount of noise. So I'm not using the display, I'm using the scope. This was even hard to do on the analog scope, so I'm glad I got the Rigel because this thing's moving all over the place. And I need to do R1023 now. The frequency trim for the lowest noise. Right about there. Yeah, it wants me to play with them a little bit. Ooh, I got better. See, that's the wideband noise. That's with no filter put in. It's just completely blowing the scope out of the water. It's crazy. Okay, here's why I couldn't do this earlier. I didn't have enough of these. You need 3 10x attenuators, a 50 ohm pass-through. I've got 7 kilohertz of signal at 3 millivolts coming in, and this is the 505. So the 505's off right now. This is coming down. This is coming in. We're going to collide a bunch of signal at this point. It's going to mix, and then we're going to adjust the distortion of the signal that comes out. But this should give us a very precise 1% distortion signal, which is what we're actually going to be adjusting for. See, I take the 80 kilohertz low pass out, and it goes nuts. Fortunately for my needs, I'm not doing distortion measurements on low distortion signals. I'm doing distortion measurements on very high volume signals because I'm testing amplifiers. So I've turned the FG501 off by just telling the oscillator it was triggered. I've adjusted the amplitude of the SG505, turning the oscillator back on, and we're going to THD plus N. We need to cal this for 1. Give it a little more. There we go. All right, cool. Turn the oscillators off. There we go. Okay, I have to adjust the function generator to 0.8. I actually have to take the terminator off. Okay, so lots of things changed for this one, the SMPT cal. I had to adjust the output of the 501. That's fed into the unit. I also had to adjust the frequency of the 505 to 7.2 and had to hit the intermod test signal, but I have the 400 hertz low pass on, so that's kicked out, and I got it to 80 millivolts. I have intermod on. This is all set. Now what I need to do is release the 400 hertz high pass, pull that out, and then do intermod. And I need to adjust R1001, which is this guy right here. I'm sorry, that's the wrong pot. I'll have to do that next. This is the one we need all the way back in the back on the intermodulation board. There it goes. Take some time in that section. Make sure you set up the signal correctly. That is, I had to read through it a couple of times. That one's actually pretty confusing on how to set up. I got to do 12, the CCIF, because I just butchered that adjustment. That's this pot. So intermod's this pot, CCIF is this pot. So we'll get that one done. I'll set that up, and then I'll be back. Okay, so I set the level button. All the filters are out, turning off the intermodulation signal. So what I need to do is I need to change the function generator's frequency to 250 hertz. I'm using my frequency counter to set the frequencies. Now I'm backing it down to, it's set to 250 hertz. Now I'm backing it down to 3 millivolts. Turn that on just to cut some noise down for now. Okay. There we go. Okay, so the SG505 needs to be at 14 kilohertz. Now the way I'm doing the frequency on this one is I'm using the sync port to hook up to my frequency counter so I can set the frequency very accurately. Turn that on. So I need 14 kilohertz. So to get that, it's actually going to be 1.4 with a multiplier. Okay. Now I'm going to need to adjust. It wants a reading of 382. Okay. Now we need the IM, that button. And this now needs to be adjusted for 1%. So it's way out. That was the one that I botched earlier, which is this one. There we go. Thanks for stopping by the lab, taking a look at this, finishing up this AA501A. One of my favorite parts. Just reminding myself I've already done it. And going through the alignment and calibration with this one. This finishes up this unit. This is now 100% working again. Everything is good to go. So it will be finding a home up there. There's a 4-bay plug-in. I'll be moving some plugins around and it'll find a home in there. One other question I got with this the TM500 system, 5000 system. Unplug this so I don't get zapped. Does it matter that I calibrated that in that frame and I'm going to put it in that frame? The real answer is no. The only thing the frames are providing are the bulk filtering, the power supply, and these two pass elements. Every frame has a PNP and an NPN transistor that's outside the frame. Most of the time those are used in the power supply, like regulation elements, things like that. So as long as the power supply is outputting the voltages that it's spec'd for, and there's enough current available so the voltage isn't sagging, you can move these around and it doesn't affect the calibration at all. When you sent one of these back to tech, they didn't need the power supply. They calibrated it with their own power supply and they sent it back to you and it was calibrated. So feel free to move these around. Same thing with the scope plugins, as long as the frames are good. Unless you have a specific plugin like the 71CT, which is the curve tracer, that specifically says it stays calibrated to the frame and the bay. But that's that specific plugin. Everything else can move around, things like that, and it doesn't affect the calibration at all. So he'll go up there. We'll be done. I'll probably keep this as my test supply. It's nice and just square. And then the 3-bay that I was using will probably get the scope cal plugins again. If I'm going to put the calibration plugins in it again, the 503, the PG506, and the TG501, I may rebuild the power supply just to know that's not going to have a problem. Because, yeah, I don't want to have to replace those plugins. Anyway, thanks for stopping by the lab, taking a look at this distortion analyzer. This guy's done. And I will see everybody in the comments section. Thank you for everybody who has subscribed and given me ideas for videos. I am adding stuff to the list, so if there's anything you'd like to see, let me know. I'm going to be branching out a little bit to where it seems like I'm just restoring Tektronix gear. I've had a lot of Tektronix gear in the queue, but I'll be adding some other manufacturers as well, so it's not strictly tech gear. But if there's anything you'd like to see, let me know. I'll see you guys in the comments and in the next video. Thanks a lot and have a good day.